Alright, so let's do LeetCode problem 235, lowest common ancestor of a binary search tree. So basically what it's asking is, given tree nodes P and Q, find its lowest common ancestor. So let's look at an example. P and Q are 2 and 8. Its lowest common ancestor will be 6, or in other words, its parent node is going to be 6, its common parent node. So another example, if P and Q are 7 and 9, then the lowest common ancestor will be 8, since it is a common parent node, the first common parent node. So one of the edge cases that we have to think about is a node can be a descendant of itself according to the lowest common ancestor definition. So if P and Q is 2 and 4, 2 would be the answer because it can refer to itself as a lowest common ancestor. So what logic are we going to apply here? We know that in a binary search tree, the left child node is always going to be less than the parent node, and the right child node is always going to be greater than the parent node. So if P and Q are both less than a parent node, then we know to search the left subtree, and if P and Q both are greater than the parent node, then we know to search the right subtree. Let's just comment that. If P and Q are both less than root, then search left subtree, and if P and Q are both greater than root, then search the right subtree. Okay, so let's look at an example of this. Say P and Q is 7 and 9. Okay, our first root is going to be 6. 7 and 9 are both greater than 6, so we know to search the right subtree. Okay, and then when do we know when to return the lowest common ancestor, or when to return root? If P and Q are on different sides of root, then return root. Because we can see that 7 is on a different side and 9 is on a different side. If we had 3 and 5, right, then 3 and 5 are both less than 6, go to 2. 3 and 5 are both greater than 2, go right. And then now 1 is less than parent and 1 is greater than parent. So let's code this. While root, and we know that this is not going to be an infinite loop because we are guaranteed a solution, right? So while root, if p.val less than root.val and q.val less than root.val, root is equal to root.left, else if p.val is greater than root.val and q.val is greater than root.val, root is equal to root.right, else return root. So this is when we search the left subtree, this is when we search the right subtree, and this is when the nodes are on different sides and we found the lowest common ancestor, so we return root, right? So let's look at an example. 7 and 9. 7 and 9 are both greater than root, so this condition will be satisfied. Then our root will go to 8. 7 and 9 are on either sides of 8, so none of these will be satisfied. So we know we found the lowest common ancestor and we return root. So the time complexity of this is O of log n, because we are searching the length of the binary search tree, and the memory complexity is O of 1, or constant time, because we aren't using any sort of data structure.